Here is a great calculus question a friend sent me for his daughter, which I'll solve now. A wall of height 8 meters stands parallel to and also from 20 meters from a tall building. Okay, so that it's two parallel structures facing up. A ladder with its foot on the ground is to pass over the wall and lean on the building. What angle will the shortest such ladder make with the ground? Okay, so there's a visualization. There's the wall that's 8 meters. That's the building. We don't know the height of the building, but we don't need to. The ladder touches the ground and touches the building. So the building, of course, goes higher up. And we know this distance. This is 27 meters. That's from the wall to the building. The wall is 8 meters up. And this distance we don't know. I'm calling this angle theta. And what I like to do is what's given to me, I put in pen, and what I decide afterwards, I put in pencil. So I always know where I stand, like if I have to redo the diagram, which means I made my own little mistake. That theta I made up, so that should have been in pencil. Anyway, these are similar triangles, so if that's theta, that's theta. This little piece of the ladder I call x, that little piece of the ladder I just called y. Therefore, L, we want to minimize L, the length of the ladder, that is x plus y. So, using rules of trigonometry, the sin of theta is 8 over x, opposite over hypotenuse. Now, manipulating equations, if sin theta is 8 over x is 8 over sin theta. Therefore, x is 8 cosec theta, because cosec is 1 over sin. Sin is opposite over hypotenuse. So at cosec is hypotenuse over the opposite. And also the cos of theta is 27. That's also 27 over y. There's cos theta is 27 over y. You get bonus points if you can read my handwriting. Manipulating the equation, y must equal 27 over cos theta. And therefore y is 27 over 27 times sec theta, because 1 over cos is the same as saying sec. Cos is adjacent over hypotenuse. Sec is hypotenuse over adjacent. Well, what we agreed earlier, the length of this ladder is x plus y. Length is x plus y. And substituting the 8 cos theta and 27 sec theta, the length of the ladder is 8 cosec theta plus 27 sec theta. So now we have an equation where L is the subject of the formula. That's great. That's what we want to minimize, is the length of the ladder. That's the whole purpose. So now that we have an equation for the length and just one variable, which is theta, we can go ahead and do the derivative. Now, if I want to impress you, I can say I knew these derivatives by heart of cosec and sec, though I looked up in a table. So there we go. So the derivative of cosec is minus cosec times cot. I put that bracket in to multiply by 8, so it's easy to show it's 8 times that bracket. And the derivative of sec is sec times tan, and 27 is still outside. And as I said earlier, you get bonus points if you can read my handwriting. And so what we do, if we want to set this equation to 0, we find I beg your pardon, we want to minimize or maximize this equation. We take the derivative and set that derivative to 0. And what I did is I just put the positive first and put the negative second. It's a bit easier. 8 times minus cosec cot is 8 minus 8 times cosec cot. Now, if that is set equal to 0, the left side must equal the right side. If a minus b equals 0, a must equal b. So I just set those. And what I do now is I just manipulate the equation. I divide each side by 27, and I divide this side by cosec cot. So from that equation, we get to this one. 8 over 27 is sec tan over cosec cot. And that simplifies to this equation. The sec brought to the bottom is cos, and cosec brought to the top is sin. which we have here, because sin is 1 over cosec and cos is 1 over sec. The tan I keep exactly there, I don't change that at all, and 1 over cot is tan. And sin over cos equals tan, so we really have tan theta times tan theta times tan theta. It's not quite correct because I forgot to write the theta in, so that's not setting a good example. If you left that out in a test, depending on your teacher, you may or may not lose points, but I should write theta with each one. So we really have tan times tan times tan theta times tan theta times tan theta gives us tan cubed theta. That's tan theta times tan theta times tan theta, which is 8 over 27. Therefore, tan theta is the cube root. If that's the cube root of tan cubed is tan, the cube root of 8 over 27 is 2 over 3. Now, if I do the arctan, the tan minus 1 of the tan of what angle gives me 2 over 3, I plug in my calculator. With degrees, it's 33.69 degrees or 0.588 radians. So that angle at the base of the ladder will minimize the length for that ladder.